Assalamu alaikum friends. How are you? I hope you are fine. You are doing well in maths. You are practicing the sums. Okay, let's begin with the next exercise. Exercise 2.6, question number 1. In this question, we are required to identify the following statements as true or false. The 7 statements are given to us in which we have to recall the concepts related to the complex numbers. Let's begin with this question to find out whether which statement is true or false with the help of solution. The part 1 in which we are given the product of under root minus 3 and under root minus 3 we can write as 3 multiply minus 1. 3 multiply minus 1. According to the properties of square root, we can separate them. Under root 3 multiply under root minus 1. Under root 3 multiply under root minus 1. And as we know that under root minus 1 is iota, so therefore we write as under root 3 iota. When we multiply two values in under root, the property is applied and under root sign is taken as common. Iota into iota, that will become iota square. The pair applying law of power, sum of powers, 3 raised to power 2 under root iota square, we put the value minus 1. Square is cancelled by square root. Therefore we have 3 into minus 1 and that is equal to minus 3. But according to the statement, it is equal to 3. So the real logic, according to this real logic, we get that the left hand side is not equal to 3. Why? Because we get the answer minus 3, but in the statement we have 3, so they are not same. Hence the statement which we write over here, that is false. Now we do the part 2. In part 2 statement, iota 73 is equal to minus iota, and we have to verify the answer by the solution whether it is true or false. Iota 72 plus 1, iota 72 dot iota, iota 2 into 36 dot iota, iota square whole power 36. And what we know that iota square is equal to minus 1, and simply negative number having even number power become positive, so it is 1 dot iota and that is equal to iota. But this thing will not match to the right hand side of the second statement, hence we can say that that statement is also false. Let's do the verification for part 3. Iota 10 is equal to minus 1. Iota 10, as it is an even number, so we write as iota 2 multiply 5. Iota 2 whole power 5 is equal to minus 1 whole power 5. Negative number having odd power will remains negative, so it will be equal to minus 1, and we observe that the right hand side of the third statement is minus 1, so hence that is same, the required result is the same, hence we write the statement as true. Let's begin with statement number 4, verification of the statement number 4. Complex conjugate of minus 6 iota plus iota square, that is what we have to given, and we are required to prove that what? Okay, its complex conjugate is minus 1 plus 6 iota. So let's do it. Minus 6 iota plus, putting the value of iota square, that is minus 1. We have minus 6 iota minus 1, writing in proper form, minus 1 minus 6 iota, and its conjugate. What is its conjugate? It's simple. Conjugate is obtained by changing the sign of the iota. So we have minus 1 plus 6 iota, and that is the same value in that fourth statement. Hence, what we write over here, that is a true statement. Now we verify the number 5 statement whether it is true or false. Difference of a complex number z is equal to a plus b iota and its conjugate is a real number. So we have to prove it whether it is true or false. So as we are given our complex number z is equal to a plus b iota, so its conjugate will be z bar, and it is written equal to a minus b iota by changing the sign of the imaginary part. Plus to minus, we get its conjugate, that is z bar. And we are going to find out the difference, z minus z bar, that will be equal to a plus b iota minus a minus b iota. Open the bracket, a plus b iota, minus is multiplied to a, minus minus plus b iota. A minus a are like terms having different signs, they are cancelled. 1 plus 1, 2b iota. And what we observe, the difference of z and z bar, mean difference of the complex conjugate, is an imaginary number, because 2b iota is an imaginary number, right? So therefore we can say that difference of a complex number z is equal to a plus b iota and its conjugate is a real number, that is false statement. Let's move to the part 6. If a minus 1 into minus b plus 3 iota is equal to 5 plus 8 iota, then a is equal to 6 and b is equal to minus 11. So we have to find out the values, whether they match or not. If they match, then the statement is true, and if they do not, then the statement is false. So we do the part 6. As we know that these are two equal complex numbers. These are two equal complex numbers. That means their real parts are equal. The real parts are equal, as well as their imaginary parts are also equal. That is, a minus 1, the real part, equal to 5, and minus b plus 3 is equal to 8. Let's simplify. A is equal to 5 plus 1 is equal to 6, whereas minus b minus 3 is equal to 8. Minus b is equal to 8 plus 3, that will be equal to 11. Minus 1 is taken to the right hand side, it becomes 11 over minus 1, that is b is equal to minus 11. What we observe, the value of a is 6 and b is minus 11, and that definitely matches the value given. Hence, that means the statement is true. Let's verify. Let's check the result of the statement number 7. Product of the complex number and its conjugate is always a non-negative real number. It means we have to find out the product of the complex number and its conjugate. We have z, we have what? Z as our complex number, and we have z bar, its conjugate, z bar, its complex conjugate. Now we find the product. Dot means multiply. We multiply these. Simple evaluation method is that first a is multiplied to the whole expression, a minus b iota. Then the second term plus b iota is also multiplied to the a minus b iota. A into a square, bracket mean multiply, a into a square, powers are added, a into b iota, that will be equal to minus a b iota, plus into b iota into a b iota, plus minus minus, b into b square, iota into iota square. We have like terms, different sign cancelled, a square minus b square, iota square. We put the value of iota square, that is minus 1, a square plus b square. and that is definitely a real number. Why? Because if we put any number in place of a and b, then that they will definitely give us a real number. So hence, product of a complex number and its conjugate is always non-negative real number. So it is non-negative. Why? Because when we put any value, any positive or negative value, their square will be positive, a for a and b, hence the final conclusive result will be a positive number always. That will mean non-negative real number, hence that statement will be definitely is a true one.